Hey everyone, back on the Philco 19-inch briefcase. Just one last check before I do final disassembly. I've taken the tube out of where we're at on emission. It's right at 5 on this 19 ABP4. And in my last video I showed that I'd recently bought another 19 ABP4 as a backup off of eBay. And received a comment that said, hey, and it tested really great, almost brand new. And I got a comment that said, hey, do you think that someone could have rejuvenated that tube and then sent it out as a good tube? Well, I'm 99% sure no, because if you use the rejuvenation function on a tube tester, unless there's one out there that I'm not aware of, it assumes that it's a 6.3 volt filament in the tube, not a 2.68. Alright, I have tried on 2.68 volt filament tubes in the past on 2 of them. To use even the lowest setting of rejuvenation, and it fried whatever emission it had left. It just glowed big, and it just blew it whatever it had left. Now both those tubes were you know, on their last leg, barely showing any emission, so it was a last ditch effort on my part. But I rather doubt that anybody could use the rejuvenation function on a 2.68 filament tube, CRT, and get any plausible results. So that's my opinion on that. You know, and that tube that I purchased, I think I paid more for shipping than I did for the tube. That's how cheap I got it. So it was a roll of the dice. If the tube is any good, but it actually tests better than this one does, but this one's perfectly acceptable. So I'm going to go ahead with the restoration, and now I'm just taking it out of the front bezel, and it's secured in by a band with some clips that clip into the plastic with some rubber seats. And that's really all there is to it. So I'll be getting the tube out, cleaning it up, and then we'll get a look at the bezel and the safety glass, because if you recall from the first video, I suspected somebody tried to paint this set. It was originally gold, no doubt. It's called a Golden Sportster, but it looked to me like somebody tried to paint it from the outside. So anyway, we'll get a better look at that in a little bit. Okay, so now I have the picture tube out of the bezel and the safety plastic, I should say, instead of safety glass, and we can get a good look at that. I've removed the speaker from the chassis. We'll be setting that side, have some cardboard on it to protect it, but now we can get a look at this bezel, and it's actually in pretty good shape. It just basically has some clips with those rubber pieces I was showing you, holding it in one band. One thing that's going on here is I've got a crack on this foot. Definitely will be super gluing that and then coming back in with some epoxy on this side. Definitely try to strengthen that back up. This side has a crack as well, which is pretty common on these sets. It's pretty common. A lot of weight put on the front of this TV set and this bezel that has these feet molded into it. So yeah, it's got some paint flaking, but that's okay. We're gonna repaint this whole set. We'll also paint the inside here, this interior, that has the Briefcase 19 as well as the Golden Sportster. That'll be a different color, and it's really too bad it says Golden Sportster because this set will not be gold again. I have different colors in mind for this because I think the gold is, well, it's just not my thing. And here is the safety plastic. I don't know if this is going to come out on the camera or not, but it is. It's in good shape. It's not cracked or anything, but it sure has a lot of blemish. It almost looks like a kid at one point in time, you know, took something and did what kids do and marked all over the middle of it. Some of these, I mean, those are pretty good scratches. So I don't know if wet sanding this, I'm really gonna have to think about this. I know I'm not gonna get it perfect or anywhere near. You can also see that this plastic has started to deteriorate like all plastic does, and it's kind of got a yellow tint to it in some places. It's kind of got a yellowish, greenish tint to it anyway. And here's why I thought that somebody had tried to repaint it. That's gold paint right there on the safety glass, and I just can't imagine that happening at the factory. It could have, I suppose, and didn't. It got past quality control in the Philco plant. I'm not sure. But it doesn't really matter. Going to try to repaint the whole set anyway. But it's all for naught if I can't really get this safety glass in at least better condition. No, I haven't even washed it. I haven't even done anything to it. So more to come on this. Try to figure it out. So where am I at on the chassis? Well, have pulled all the tubes, and these are all the bad tubes in the set. 1, 2, 3, 4, 5, 6, 7, and then this is the high voltage rectifier, which it's the 1G, 3G, and I didn't even bother to test this. I just pulled it. It's one of these cool chassis Philco TV tubes. In fact, all of these are, except for this little UHF tube. This little 3AF4 for the UHF. It tested horribly too. But all these tubes tested terrible. But I now have new tubes for all of them. Sounds like my neighbor's dog is excited about that. All right. So what else have I done? Well, not much. Getting ready to start in on work on the power supply and replacing these electrolytic caps. I'm going to replace all of them. Sometimes when I'm working on vintage sets, if these caps test good, I won't replace them, especially on a set from the 60s, early 60s and on. But where these are located at within the TV, you don't really want to be breaking it down to this level again, at least for quite some time. So for purity's sake and for the sake of somebody down the line that may get a hold of this set and knows that it's restored, hopefully the new caps I put in will last 20-25 years, and they won't have to worry about replacing these. And there's a couple of components down here that are pretty important to the power supply, and I'll talk about that right now. Or wait a minute, I'm not going to talk about that right now. because in the last video, when we broke the set down, I got a comment from a viewer that was intrigued by the fact that I found a little transistor inside the set, and I have to admit I was too. I don't know what this little guy was doing in there, if this set was in a shop at one point in time, and somehow some stock or something from, it was on the bench and it accidentally got knocked into the frame of the set, but there's absolutely no reason for this transistor to be in the set. I suppose it could have fallen through a cooling fan when it was in a TV shop or whatnot, but had a comment saying, hey, why don't you go ahead and test that transistor? So I'm going to go ahead and do that now. And it's an NPN silicon transistor. So the red is the collector, the green's the emitter, and the blue is the base. Okay. There's the gain. It just shows the test current of 2.5 milliamps. From base to emitter, it's 0.084 volts. And there's no leakage. So it's good. I have to throw him in my semiconductor parts bin. I don't know what it's for. I don't even know what it is. You guys can't see that, but I can. It's an ERS 108. No idea. It's not going to let me show it to you. No idea what kind of transistor or what the application for that transistor is. But anyway, there you go. It's a good transistor. Okay guys, I've dove in and started in on work on the chassis, and I thought I'd point out a couple of things. I am at the point right now where I'm starting on the power supply, and this is the SAM schematic for this set, and just thought I would show you a few things that I'll be doing. And also tell you a few things about how the power supply of the set works. But basically, line input is right here. And so if you look at the schematic, one side of the line goes straight to ground, and then one side of the line comes off to M2. And in between that is a line voltage cap, a 0.1 microfarad. And that is that black bomb right there. Okay, and that's rated for 600 volts DC. I will be coming back with a safety cap that's rated for 250 volts AC. This cap is in there. It's actually a pretty important thing. It's basically a doorstop, if you will, where when this set is plugged in, voltage is on that cap at all times, and it's a 600 volt DC rated cap. That's a lot less than a 250 volt AC rated cap. Why is that there? Well, it's there to mainly do two things: bleed off any RF that may get in your line, your line source throughout the whole power grid. The grid is collecting radio frequencies. It's inside your house. It's collecting frequencies from computers, refrigerators, whatnot that you may be running in your house. And it's simply designed to help filter that off when the set is turned on. The other thing is, this is an important safety feature, in that if that cap were to short, I'm sorry, if it would just go open, you could basically have a hot chassis. You could have a hot TV and a good shock. So that's the difference between that cap that's in there and this cap. This cap's designed to short, and therefore nothing's going to go any further. So this M2 here, this set actually had a bulb type remote control that you could use. That option's not on this set, but that's what that is. On the schematic, it was fed by air, and then it would simply come down here to the on-off switch and turn the switch on, allowing power to go in. So a couple things. Power goes in, and then on the B plus side, it goes to this 5.6 ohm fusible resistor, which is right here. Now, that's a new one. The one I showed in part one was still good, but it was crumbling. It finally just fell apart. So I put in a new fusible resistor. It's 4.7 ohms. That'll be fine. But power then runs all the way up through here and goes into this fusible resistor. All right. We'll talk about this side a little bit more in a second. Well, we'll go ahead and talk about it. C2, which I've already replaced, which is this cap, 125 microfarad cap that is connected to the line and then goes straight to ground. Then it goes into basically a voltage doubler right here, these two diodes, and they're located right up here. Okay, so the power then goes from here down to back behind here and then back up to here. And if you take your time, you can trace all this wiring throughout this whole frame, and that's kind of what I've been doing so that, you know, I understand how this power supply works in case I have a problem coming later. Then it goes into this filter choke right here. Okay, so then power goes from the filter choke back down to these capacitors right here, which is C1, C3A, and C1B. Okay, so basically what this is, this now becomes, after it's filtered through the choke, it's our B plus source 245, which powers most of the set. There's a 1500 ohm resistor to get us down to a 235 volt source. There's a 2000 ohm 10 watt resistor that basically takes the voltage down from 235 to 155. And then there's one other resistor in there, a 3500 ohm 5 watt resistor that will supply the 135 volt source, which those are the 4 different voltages that the rest of the set uses. So that's why I'm starting on this, just making sure that I get this right, because if you don't get this right, you really don't have a chance for all this to work correctly. The other side to it is the other side of the power out of the switch goes through a 32 ohm 10 watt resistor, which is right here. That is seriously low. I think it's measured it was like at 12 ohms. So I'll be replacing that. I don't have one. I've got one on order. Then it goes into a 200 ohm cold, 10 ohm hot thermistor. And that is right there. And I'll be replacing him with this. This is a 200, I believe it's a 220 start, which will be fine. And then it goes into our filament string. Now it's kind of curious that it says that that thermistor is used in the UHF equipped models. I'm not real sure why that is. Maybe somebody can point that out. There is an additional tube in the string versus the VHF model. But what this basically does is when you turn the switch on and there's an inrush of current, it has a high resistance, And as the tube filaments warm up and there's the power is going all the way through the set or the string, then this will slowly go down to, you know, very low ohms, 15, 20, 10 ohms, somewhere in there. VHF model doesn't have that. And again, I'm not sure why. I wouldn't think that one additional tube would require a thermistor, but that's the design. So I'll be replacing those parts as well. Now, one thing curious to note as I turn this chassis around, I've already started and done some work back here. This is that 125 microfarad capacitor. That was an isolated capacitor. That's why it had this brown covering to it, because it was grounded to itself, which means that if you were to touch this, you might get a pretty good shock. So what I did was just took the sleeve off. I'm coming back with 150 microfarad, and it's rated at 450 volts, which is way overkill. I could not find 125 microfarad electrolytic cap, so I'm using 150. I think it'll be okay. You definitely never want to go below that 125, and going up will probably be okay. That's just mainly a filter cap to bleed off ripple and stuff that's coming in through the line. It's one of the first things it hits. So that'll be okay. What's curious to note is this 2000 ohm 10 watt resistor here that drops the source from 235 to 155. It's located right down here. It's hiding back there. I've already replaced it. This is the one that came out of it. And what's interesting is it's a 2700 ohm. So my first thought was, well, Sam's has been known to make mistakes, but it shows on the schematic 2000 ohms, 10 watt. It shows in the part list the same thing, and so it's one good reason why having the original Philco information is good to have as a backup. And if you come through here and you look at that same, basically it's a voltage dropper. It says 2K ohm as well, 10 watt, and I looked it up on the parts list here. So I don't know if there was a revision. There's nothing noted in either of these service bulletins that there was a service bulletin or a production change for certain runs. I don't know. I have not found anything on here that indicates what run this would be. So this resistor was right on 2700. So for all intents and purposes, it was good. I should have left it in there. But I'm going to go by what the data tells me, and it tells me it should be a 2K 10 watt resistor, which is what I put back in there. Okay. So it's kind of interesting when you really look at the power supply and realize where power is going. It's coming in, it's going up, it comes down, it goes back up, it splits off to B plus, and then it comes down and connects to the circuit boards. The AC part does, and lights the tubes and runs the filament string. So, you know, I try to trace out which lines are going to what so that I know where everything's at, and then it also makes it a lot easier when you start to take off these circuit boards, what the layout of the power supply is on both these boards. Next thing I'm going to do is I need to replace this 1 microfarad 50 volt paper cap. I don't have one of those. I've got one ordered. And then this is that what is this? This is C3, I believe. Yes. And it's a 4-section cap. Be coming back in with a strip. Get rid of that can. I'm going to get rid of this can too. I think it's a 3-section cap. Just going to get rid of all the electrolytics back here. Some of you have seen me in the past. If these things test good, I'll leave them in, especially from a late 50s, early 60s set. If they test strong, I have no problem leaving them in. But due to the nature of where these are located in this set, I don't think I want to fool with having one of those go bad at a later date, or a few years down the road, someone has this set, they know it's been restored. They may or may not be able to replace these. It'd just be better to replace them. At least I know they'll have another, hopefully 20 to 25 years, 30 years, depending on how long modern day caps will last in the future. Who knows if they'll. So it drifted upward, and it was fairly leaky. So it's good that we replaced that one. But to get to this point, to be able to work on it, to pull the set this far apart is, I don't want to say it's a design flaw, but it certainly didn't make dealing with electrolytic caps in this set very easy. In most sets, you can pull off the back and quickly identify cans for the electrolytics and either access them at the top or under the chassis. So due to the nature of how they confine this whole TV set into this square picture frame, as I call it, they really didn't have a lot of space to put capacitors on that side, so they chose to put them down here. But anyway, I'm going to go ahead and finish recapping this off, get this cap in, and be done with this front side, and then I'll attack the circuit boards. So when I get that done, I'll bring you guys back and talk a little bit more about the set. Okay, so I've finished up changing all the electrolytics in the set. Starting out, I showed this before. This is a single cap. Replaced it with 150 microfarad. It was a 125. I reused the protection sleeve. Here was a 4-section cap. All right, that was tucked down in here. I simply just tucked 4 new replacements in here. Wired them in. They have a common ground there on the old lug that held that in place. These guys are tucked in here nice and taped up. Replaced a couple of resistors and a capacitor. This was the 3-section cap. Just came back with a power strip. A power strip. That's not a power strip. That is just an electrical strip. They're all wired in and secured. Really the only thing I have left to do on this whole side is replace this 1 microfarad 50 volt cap. I don't have one of those. I have one on order. It should be here tomorrow, so I will change that out as soon as I get the new cap. So with that, really only have 2 concerns with what's going on in the back side here. One is, as I was talking about, that's a 2000 2K ohm 10 watt resistor. That's what the schematic calls for. What I pulled out of there was a 2700 ohm. I don't know if somebody replaced it with that 2700 ohm at one point, because that's all they had. It was close enough, I guess, for them, or if it was a run change that I don't know about on this set. Not real sure, but I guess we'll see when we get to the point of powering up the set if those secondary voltages from the power supply are off. That could be one potential possibility. The only other concern I have and goof up I may have done here, and I don't know if you can maybe guess what I did that could be a problem just by looking at it. And I know I worked on a Philco Town & Country, which the backside is almost identical to this. But what I'm talking about here is this strip that I put in. If you notice, this little tab here actually is a ground point for the CRT. And I cannot remember how I dealt with changing this cap out. But this cap, if it was installed, would not stick out as far as that strip does. So I'm kind of concerned whether when we go to reinstall the picture tube, if that will butt up against the picture tube, which would not be good. So I guess when I get to that point, I'll worry about that. There's certainly different ways I could have put these caps in. And what I was going to do was put this cap over here, make it farther back in, and then this smaller cap over here. I don't know if it'd make much difference because I'm still concerned about the edges of these terminals on this terminal strip. So we'll see. May have to come back and redo this, which I hope I don't. I hope it works, but we'll see. So other than changing that cap, I'm really done on this side, and it'll be time to turn it around and start working. I think I'll start working on that circuit board next.